In this video, we will explore how to get started with the PIC32CM JH01 MCU using the Breakout board solution MCU Sample Kit 1. This 32-bit Arm Cortex M0 Plus based microcontroller demo showcases LED toggling and UART output triggered by switch press using MPLAB code configurator, also known as MCC. Download the MPLAB Harmony v3 repositories and install the required software shown here. You can use MCC Content Manager to clone these Harmony packages. If you are new to MCC, be sure to watch our introductory video. You can find the link in the video's description. The Breakout board solution, MCU Sample Kit 1, is a hardware platform designed to evaluate one sample from each of Microchip's major microcontroller family, including the 8-bit AVR, ATtiny 1614, PIC18, F26Q71, 16-bit DS-PIC 33CK32 MP502 and 32-bit PIC32CM 5164 JH01 providing developers with a simplified way to prototype, test, and integrate each MCU into custom designs using external tools like the MPLAB PIC85 and the MPLAB X IDE. Our goal in this video is to toggle the LED on a timeout basis and print the LED toggling rate on the serial terminal. The periodicity of the timeout will cycle between 500 milliseconds to 1 second, 2 seconds, 4 seconds, and back to 500 milliseconds each time the switch is pressed on the breadboard. To achieve this, we will set up the hardware, download the project from the kit page, open the project and launch the MCC, check the peripheral configurations in the MCC, review the application code, then compile the project and see the output. Let us begin by setting up the hardware. Start by placing the MCU Sample Kit 1 on the breadboard. Then make the following connections. Connect the LED to pin A17 through a 1 kilo ohm resistor. Connect the push button switch to pin A16 with a 10 kilo ohm pull-up resistor. Use a 100 microfarad capacitor for filtering between power rails. Connect the USB to UART bridge as shown in the screen. Next, plug the MPLAB Snap debugger into the J13 programming header and connect it to your PC with a USB cable. Also, connect the UART bridge to the PC. To get started developing applications on this board, open the web page for this sample kit shown here. Download the zip file for the Getting Started demo project. First, extract the demo firmware and open the project in MPLAB X IDE. Go to Tools, Embedded, and open MCC, which will open the project graph. Review the configuration of the key peripherals used in this project. Here, External Interrupt Controller is configured for switch press interrupt. RTC is configured for generating timeouts. Also, the Circom USART is configured for UART communication. If you want to configure other system-specific peripherals, use the drop-down menu under Plugins and choose the system module you would like to configure. For example, to configure the clock, open the Clock ECView window by clicking on Clock Configuration. You can use MCC to add another peripheral, reconfigure the project, and generate the code. You can go to the project configuration path anytime and check the various files to understand how the project is implemented. This application demonstrates a LED toggle on a timeout basis and prints the toggling rate on the serial terminal. This code uses UART to send the strings periodically. The periodic timeout can be changed by pressing the switch on the board. Under Project Properties in MPLAB X IDE, select the target kit in the Connected Hardware tool dropdown. Then click OK. Open a terminal on your PC such as Term and set up the serial port. You can now use MPLAB X IDE to build your project and program the evaluation kit. Here, you can see the LED's toggling rate periodically displayed on the console. The periodicity of the timeout will change from 500 milliseconds to 1 second, 2 seconds, 4 seconds, and back to 500 milliseconds every time you press the switch on the board. Navigate to the link shown on the screen for more application demos using the Breakout board solutions and the PIC32CM JH01 MCU or other sample kits through the MPLAB Discover. We hope you enjoyed this brief demonstration. Thanks for watching.